Okay, so we've got point P moves in such a way that its distance from this point is equal to the distance from that line. So I'm gonna draw this out to see what's going on. So quick sketch. So point P from 0, 3 is there. 0, 3, and y plus 3 is 0, that's y equals minus 3. The line y equals minus 3 is this line. If I take a general point P, x, y, what it's saying is the distance of P from that point is the same as the distance of this point P from that line there. So let's call that point A, and we call this here I'll call it N. So PA, distance of PA, so I got to the two coordinates, is the square root of y minus 3 all squared plus x minus 0 all squared. And Pn, the distance of this general point y down to this point, well, y from there to there is y, and the distance then down to minus 3 is a further distance of 3. So Pn has a distance of y plus 3. I'm saying these two distances are the same. So I got y plus 3 is equal to the square root of y minus 3 all squared plus x minus 0, that's x squared. Square the left hand side to undo the square roots, that's y plus 3 all squared is y minus 3 all squared plus x squared. Expand the brackets, that's y squared plus 6y plus 9. Square this one, y squared minus 6y plus 9 plus x squared. So they're the same on both sides. They're the same on both sides. Take the 6y over, so I've got 12y is equal to x squared, which is x squared equals 12y. That's part A. Part B, show that this point lies on C. So if I just sub it in, so 6t 3t squared, I want to show it's on x squared equals 12y. So that's x is 6t, y is 3t squared. Let's just check that balances. So x squared is 6t all squared is 12 times 3t squared. Square 6t, so that's 36t squared. And then 12 times 3, that's 36t squared. Therefore, lies on C for t. Part 2, or the equation of the tangent at the point. So the point is 6t 3t squared, and the curve is x squared equals 12y. So to find the gradient, I differentiate. So just rewrite this other way. So y is x squared over 12. So dy by dx, that's 2x over 12, which is x over 6. So the gradient of the tangent at this point, at x is 6t, so that's 6t over 6, which is t. So the equation of the tangent, that's y minus y1, that's 3t squared, over x minus x1, 6t, is the gradient t. So y minus 3t squared is t bracket x minus 6t. Expand the bracket, that's tx minus 6t squared. So I go y equals tx, and bring the minus 3t squared over. It's minus 6t squared plus 3t squared. And that combines to give me minus 3t squared. Next part, find the values of t for which the tangent passes through 0 minus 12. So if the tangent passes through 0 minus 12. That's telling me when x is 0, y is minus 12. So substitute into this, so y is minus, that's minus 12 equals x is 0 minus 3t squared. Minuses cancel, 3 into 12 goes 4, so that's t squared equals 4. Square root of 4 is plus or minus 2. And then part 4, find the angle between the two tangents to C from the point 0 minus 12. So I'll just do a sketch here. C is quite an easy drawing. I've got y equals x squared over 12, so its graph is looking like that. I've drawn the tangents from 0 to minus 12, so it's down to minus 12 there. Tangents, and what I found is for t was plus and minus 2, and the equation of the tangent was y equals tx minus 3t squared. T was the gradient of the tangent, so the gradient of the tangents are plus and minus 2. So to get the tangents, that curve is symmetrical here about the axes. Okay, I want the angle between the two tangents, which is that there, which is double. This is a line of symmetry, obviously, because the curve is symmetrical. Now in the gradient of that line is 2. So the gradient of that line is 2. That's 2 over 1. Then this angle here is that angle there. So tan theta is the opposite of the adjacent, which is a half. So theta in degree mode, shift tan over half. It's 26.6. So the angle between the tangents is double that. That's 53.2 degrees.